Today's lesson is about expanding and condensing the logarithm. First of all, let's talk about product rule, quotient rule, power rule for exponent and a logarithm. For exponent, multiplication of a power, we add exponent. Division of a power, we subtract exponent. Power of a power, we multiply the exponent. For logarithm, multiplication of a argument, we add exponent. Remember, log is exponent. Division of a argument, this 2 log, you do subtraction. Power of a power for argument. Then we move down the exponents, do the multiplication. Basically, for logarithm, they change multiplication into addition. They change division into subtraction. Power of a power change into multiplication. Now let's work this out. Multiplication of a power, we add exponents. Therefore, we got the x plus y plus z. For quotient of a power, we subtract exponents. Therefore, we got x plus y minus p minus q. For power rule, we multiply by the exponents, x times y times z. For logarithm, we change multiplication into addition. Therefore, we got log base a of x plus log base a of y plus log base a of z. For quotient rule of logarithm, change multiplication into addition, change quotient into subtraction. Therefore, we got log base a of x plus log base a of y. Then minus log base a of p minus log base a of q. For power rule of a logarithm, we put the x is this power, then y to the this power. So we got log base a of x to the this power plus log base a of y to the this power. Then for exponents, you got to drop down. Therefore, we got z log base a of x plus z log base a of y. Now let's go to some example. For number 4, first of all, you need to check how many factors you have. You have 1, 2, 3, 4, 5 factor. Therefore, you are supposed to have 5 log. You do addition or subtraction. For each factor, make sure it's exponential form. For x, you will get 1 over 3rd power. For x plus 1, you got to do 1 over 3rd power. Then, above the division line, this division line, that's addition. Below the division line, then you do subtraction. Therefore, we got log base 7 of 4 add log base 7 of d add. When you have exponents drop down, so we got 3 log base 7 of f. Below division line, you do subtraction minus 1 over 3 log base 7 of x minus 1 over 3 log base 7 of x plus 1. For number 5, check how many factors you have. You have 1, 2, 3, 4. For each factor, you need to change into exponential form. So we got a do 1 over 3rd power, b do 2 over 3rd power. For y, you got to do 1/2. Z, you have to do 5 over 2. Then above the division line, you got to do addition. Below the division line, you got to do subtraction. Therefore, we got 1 over 3 natural log of a plus 2 over 3 natural log of b minus 1/2 natural log of y minus 5 over 2 natural log of z. Generally speaking, when you do the expanding the log, check the number of factors. Above the division line, add the logarithm, while below the division line, you got to do subtract the logarithm. For number 8, this kind of question is very popular for expanding logarithm. When you say something like write log in terms of x, y, z or a, b, c, means expanding the logarithm. For this question, we got log base 2 of p equals x, log base 2 of q equals y, log base 2 of r equals z. Write the log in terms of x, y, z. First step, we need to expanding the log. Check how many factors you have and change each factor into exponential form. Therefore, we got log base 2 of q, we do 1/3 power, r 3rd power stay, p you got to do 1/2 power. Then above the division line, that's adding. Therefore, we got 1 over 3 log base 2 of q minus 3 log base 2 of r minus 1/2 log base 2 of p. Last step, we need to plug in. Log base 2 of q, that is y. So we got the 1 over 3y minus 3. Log base 2 of r, that's z, minus 1/2. Log base 2 of p, that's x. This will be the answer to this question. One more. Suppose a equals log base 5 of 2 and b equals log base 5 of 3. Write each logarithm in terms of a and b. You are supposed to change each argument into 2 to the what power or 3 to the what power. For example, like a log base 5 of 8, I can do 2 to the 3rd power times 3 to the 1/2 power. Therefore, I got 3 log base 5 of 2 plus 1/2 log base 5 of 3. Then you need to plug in log base 5 of 2, that is a. So we got 3a plus 1 over 2b. For number 18, whenever you have decimal, you need to change it into fraction. So we got 20 and 1 over 4 equals 81 over 4. Therefore, you will get log base 5 of 81 over 4. Then try to change this argument into exponential form. Base is 2 or 3. So we got log base 5. 81 means 3 to the 4th power. 4 means 2 squared. Then we expanding this log. So we got 4 log base 5 of 3. Subtract. Below the division line means subtraction 2 log base 5 of 2. That equals 4 times the log base 5 of 3, that's b. So we got the 4b minus 2 log base 5 of 2, that's a. 2a. That's all. Now let's talk about condensing logarithm. Basically, it's a backward of expanding the logarithm. For addition of log, you multiply the argument. For subtraction of log, you do division of argument. When you have n multiplied by the log, you will make this n jump as an exponent, like this. For example, first of all, you need to make every single number before log jump as an exponent. N, I got to do y to the nth power. B, you got to do p to the b's power. C, you got to do q to the c power. Then next step, you will get the log. Since you have subtraction, means you have a division line. Positive go to the top of division line as a numerator. So we got x to the mth power times q to the cth power. Minus or negative, we go to denominator. So we got the y to the nth power times p to the b's power. That's all. That's how you condense the log. Let's do some example. First of all, you need to clear the log. That means any number before log jump as an exponent. So we got the x to the 3rd power. 1/2, when you jump, we go square root of 6 minus x. 4 jump, we got y to the 4th power. Then you will get the log. If you have subtraction, that means that you have division line. Base is 5, don't change. Then x to the 3rd power go to numerator. When you have subtraction, let's go to denominator. Square root of 6 minus x. Denominator y to the 4th power. That's all. For 16, clear the log first. That's a to the 7th power, b to the 3rd power, c to the 4th power. Then I got the natural log. Since we have subtraction, so we have division line. Positive go to the top, so 15 times c to the 4th power. Then subtraction go to denominator, a to the 7th power times b to the 3rd power. That's all. For number 18, 2 jump at the 3x squared. 1 over 4 jump at the 4th root of 2y. 5 we jump at the 5th power. Then we got log base 5. We have division line. Positive go to the top. Therefore, we got 3x squared times the 4th root of 2y. Denominator, that will be z to the 5th power. You can work 3x squared out. So we got log base 5, 9x squared, 4th root of 2y. Then z to the 5th power. For 23, when you have integers, how we change integer to the log? We know log base a of a equals 1. Therefore, I can do n times log base a of a equals to n. This n I can jump as the log base a of a to the nth power equals n. Therefore, for these two, I can do 2 times log base 5 of 5. So we got log base 5 squared. Make a 2 jump as this. Then minus 1/2 jump. You will get the log base 5 of square root of y minus log base 5 of z to the 5th power. Since we have subtraction, we do have a division line. 5 squared, that's 25. Square root y go to denominator, and z to the 5th go to denominator. That's it.